Hello, so we've solved some questions already on indices and we'll be taking some more questions again to solve. Now, I just wanted to just show the screen of what we've been doing. Now, let's go down, let's zoom in to where we'll be solving, where we'll be doing our next solving. So, let's zoom in here. I think this should be okay. And let's take a question. Now, I need something quite tough. So, I have this question here on the board. We're asked to simplify this question. 4 raised to the power of minus 1 over 2 times 16 raised to the power of 3 over 4 over 4 raised to the power of 1 over 2. Now this is trying to look tough, but it's not really tough. So let's solve this question. Now notice something. First of all, notice that they all have the same base. What is the base you are noticing here? Is a base of what? 4, because we know that 4 is a base here, 4 is a base here. 4 also is a base inside 16, because 4 raised to the power 2 will give us what? 16. Is that not so? So first of all, let's write them in the power of their bases. Now this is going to be what? 4 raised to the power of minus 1 over 2 times 4 raised to the power of 2, right? Yes, correct. And then bracket 3 over 4 over 4 raised to the power of what? 1 over 2. Now let's continue here. Now we have this. This is carrying a negative sign. But before I begin to touch it, let me just work with this one here. So this is 4 raised to the power of minus 1 over 2 times. Now we can see here that that the 2 can divide 4, and that's what we're then having what? 4 raised to the power of what? 3 over 2, because it's remaining 2 here after you divide it. Everything here is divided by 4 is per 1 over 2. So I can apply my addition law in this numerator side. Addition law tells us that we have 4 raised to the power of minus 1 over 2 plus, because they are all the same base, so you can just pick one of the base and add the index, plus 3 over 2, dividing 4 raised to the power of what? 1 over 2. Now let's continue. Here will then give us what? When we add this up, we know that since they are having the same denominator, we can just add up their numerator. Minus 1 plus 3 will give us what? 2. And that's like saying 4 raised to the power of what? 2 over 2 divided by 4 raised to the power of what? 1 over 2. And this will give us 2 over 2 is 1, so we're having just 4 divided by 4 raised to the power of what? 1 over 2. Okay, so let's continue. Now notice something. I can apply this law, that's the fractional law here. Look at this. I can apply the fractional law here, or I can use the division law, whichever one I want to do. So let me just bring it out and then show you 2 ways I can solve this particular one. Now you can solve anything anywhere as long as it is going to fulfill the mathematical law that's involved. So let me first solve it one way, by using the fractional law. Fractional law tells us that I have 4 over, this is like saying this 4 raised by 1 over 2 is like saying square root of 4. So square root of 4 will give us 4 over 2, and then 4 dividing 2 will give us what? 2. Is that okay? Now that's one way. Another way of solving this question, again, let me write it out. So let me use a different color for that so it will look different. 4 over 4 raised by 1 over 2 is by bringing the division sign, so that's like 4 divided by 4 raised by 1 over 2. Remember, this is like carrying a raised by 1, though it's kind of invisible. So we can then use the division sign by using the subtraction law. So pick one of the base, 4. We say 1 minus 1 over 2. What is 1 minus 1 over 2? I believe we know how to do that. So that is like saying 1 minus 1 over 2. Remember, you can now put on that denominator here, and then you pick the LCM. LCM is 2. 2 divided by 1 is 2. 2 times 1, 2. 2 divided by 2 is 1. 1 times 1 is 1. So it's 2 minus 1, which is 1 over 2. So therefore this is what? 4 raised to the power what? 1 over 2. And we can say we are done, but we can still go on further to use the fractional index law, and that will be what? Square root of 4, and that will give us what? 2. And we've gotten the same answer we got here. So you see, the same value. It's not really, I believe you've seen that it's all about following the laws and making sure you are following it accordingly. Don't try to break laws when you're working. Don't try to break laws. try to take it step by step, step by step, step by step, step by step. Notice I first did the numerator, first did the denominator. If you're trying to do both of them at the same time, you might get your working confused. Okay, so let me take one more question, and I might wrap it up for this particular topic, unless if there's any other if I find any other solving I know that I would like to emphasize on. Okay, so let's take this question here. Now I'm trying to look for something quite tough, because I had my students tell me that, sir, you don't solve tough ones, but you give us tough ones to take back home. And I've told them that that is the life of being a student. You don't expect to always take the easy one back home. You expect to take something tough so I can reason it out. Okay, let's just take this question. I think this should be quite interesting. Okay, let me just I'll take two questions, because I've seen one that looks a little bit interesting. What about this one? If they give you this question to solve, 0.0 0.027 minus 1 over 3. Okay, let's solve this question. Now this is a decimal number having an index raised power minus 1 over 3. Now how do you solve this? You solve this by first converting this decimal number into that's a fractional number. So how do you convert it? You divide it by the decimal places that it has. So how many? It has 1, 2, 3 decimal places, right? That's like saying dividing by what? 1000. So it's like saying 27, because when you count 1, 2, 3, you've entered 27 divided by what? 1000, all raised to the power of what? Minus 1 over 3. Is that okay? I want us to get how to solve all these things because it's very needful. We learn all these procedures. Then what happens next? I have this my negative sign. My negative sign tells us that this will become 1 over 27 over 1000 raised to the power of what? 1 over 3. Now there's one thing I forgot, I didn't tell you of, but I think it's one of the procedures to know. Whenever you have 1 over a over b, when you have this kind of stuff, your b flips up here. I don't want to just spend my time showing you the mathematical reason why, but just know this. So your b flips up here and it becomes what? B over a. Also, whenever you have, let's say we have let's say it is a over b over c. What happens again? Your c flips up here and becomes what? A times c over b. Is that okay? So let's just give a quick example. If we have 2 over 3 over 5, it becomes what? 2 times 5 over 3, and that's like saying 10 over 3. Is that okay? I believe that's correct. So let me wipe that off. It's just for emphasis to show you what we'll be doing next. And then so for what we'll be doing next, we have this. Sorry, I think that's too much. Okay, now let's continue. So for this part, our 1000 will come up, and then it becomes 1000 over 27, still holding your formula of 1 over 3. Is that okay? Thank you. Now what happens here? Now we can now apply this fractional index law by opening the brackets. So we have 1000 having 1 over 3 personally, or 27 having 1 over 3 also personally. So this becomes what? Now when you have this, you can then take the cube roots, because this is 1 over 3, so you take the denominator. According to fractional index law, this 3 becomes the cube root of 1000, so that becomes the cube root of 1000 over the cube root of 27, and that gives us what? Cube root of 1000 is 10, because 10 times 10 times 10 will give us 1000, over the cube root of 27 is what? Is 3, and that's the final answer, 10 over 3. Work done. Now I could have solved this thing another way. Rather than doing this by opening all this separately, I would have just applied a surd rule here by saying, let me just take, okay, let me show you what I mean. If I have this 1000 over 27, and I have this divided by, that's raised to the power of 1 over 3, I can just apply this law straight away. So applying this law, remember this is the fractional index law, this 3 denominator becomes the roots, so it becomes the third roots of 1000 over 27. But according to our surd rule, Now that's why I know I've not taught sod yet, but according to our sod rule, we know that this can be broken down to what? Third root of 1000 over third root of 27, and then we are back to what we've just done here. Okay, so that's the solving for this one. Then the last question I will take, let me take the last question. So last question, I'm trying to make sure it's a tough one. Okay, let's take this one. I think it's going to be a tough one. Now let me use my blue marker to write. I've not used blue for a while. So we have 8 raised to the power of 2 over 3 times 27 raised to the power of minus 1 over 3 all over 64 raised to the power of what? 1 over 3. Now let's solve this. Okay, let's look at this very well and notice if is there any base number that is looking alike. Really they don't have the same base number as looking alike, but I can still find some things that I can hook onto here. Now notice something. 8 can be written in the base of 2, right? Yes, that's correct. 27 also. But if I don't want to just go that way, I can just go straight away and start applying the laws. So applying the laws, I can say 8 to the power of 2 over 3 can be written as what? The third root of 8 raised to the power of 2. Remember, I showed you that in fractional index law in one of our videos. And then here is the negative index law, right? So this negative index law, I can apply it, but before I apply it, since I don't want to start applying and breaking out everything straight away, I can just transform this particular one to 3 raised to the power of what? 3. Remember, 27 can be written as what? 3 raised to the power of 3. And then here's what? Minus 1 over 3. All over what? 64 can be written as what? 64 can be written as what? Okay, if I don't want to write it that way, I can just apply the law. But now 64 can be written as 8 to the power of 2. But if I don't want to apply it that way, I can just write the law straight away by saying that is use this law of 1 over 3. So this is the fractional index law, and then I can apply it to be what? Third root of 64. Is that okay? I believe that's going well. So solving this particular one, sorry, something is itching me. So solving this particular one, the third root of 8 is what? Is 2. 2 raised to the power of 2 times this particular one. We can see here that 3 can cancel out 3 here. Is that not so? Therefore, what's remaining is then going to be what? 3 raised to the power of minus 1 over. Now, the third root of 64 will give us what? What's the third root of 64? I believe it's meant to be okay, no, not 8. That's meant to be 4. Yeah, 4. Because by now 4 times 4 will give me 16. 16 times 4 will give me 64. So it's going to be 4. Is that okay? Yes. So we can then proceed by, let me continue here. So I can proceed by saying 2 raised to the power 2 is what? 4. 4 times 3 raised to the power minus 1 over 4. Now I can tell you quite categorically that 4 can cancel out 4 here. Is that not so? And what's the final answer? 3 raised to the power minus 1, which can also be written as what? 1 over 3. And that's the end. So thank you. Now I will check you'll see questions I will drop down on indices, on solving for indices. Then the next time we come again, our next class will be working on what we call indicial equations. So where we have equations for indices where they ask us to find the value of x or the value of y. So thank you.